喂，哎，是我跟你
我
讲啊，
跟你讲啊，
你有看
你有看
你在那个
你在那个
做
做
那个 set up
set up
level 的时候，
level 的时候，
你有
你有
看吗？
看吗？
因为是这
因为
样的，
是这样的，
就是
就是
Unit 二
Unit
的那个
二的那个
slab 啊，
slab，
它有
它有
100后的，
100后的，
有150后的，还有
150后的，还有
200后的
200后
行。
的型。
对，那你
对，那你
200后不
200
行，你就
后不行，
拔去了，
就拔
当然
去了，当然要
超高的了。
超高的了。
The parents told me.
是。
是。
对啊，十
对啊，
四号用的
14号用的
拔去了，
拔去了，
然后的
然后的
话有一
话有一
家公司，
家公司，
我叫磊磊
我叫磊磊
去
去
那
那
个
个
She's asking about something.
He wasn't talking to us.
She wasn't.
No.
I can't really understand what the vertices of the hole are not on the border on the page.
It just means if you have a triangle, the corner can't touch the side of the square. No? The corner of the triangle can't touch the edge of the square.
Oh.
You filled it all with numbers? You think you solved it? Oh. How about you, Ernest?
But I realized it was on 5 and the list was set to floating. That is again.
Okay, I'll give you a little bit more time and then we'll talk about it, okay? About 4 more minutes. Yeah.
So this was as a 4x4.
Hey, I
It
like.
was like a 4x4, but it wasn't.
Is that a 9?
Yeah.
That's a 4 or 2? 2? Okay, so maybe you check the 9. Check if the 9 can be. Do you see?
钢筋嘛，这东西，最多就是我们把
Alright, guys, you ready? So how did you do it, Caleb? Can I have a look at your thing? Put this up on the screen somehow. Yeah, you can see it's very different. Usually you have lots of questions and very little time, right? Here you have very few questions, a lot of time. Okay, so let's have a look at this question. Right, can you see that? Yeah. I just took a photo of it. Okay, do you see? Can you see it, first of all? Or do we need to zoom on that a bit? It's like 6 3 1 3 1 3 1 2 3 1 3 1 3 1 5 1.
Wait, what's that? The scribbled
Is that a
number.
1?
What's the
Three.
that scribbled number though? Scribbled number.
1 3 3 1 3 3 1 5. Is that a 5? Okay. 1. Okay. So that looks kind of random. Why is that the solution, Caleb? Hmm? Okay, so what do we actually need for this to be a solution, first of all? Yeah, what's the condition? Yeah, so in some order it has to be prime, yeah? So, for example, that 3 goes with that 1, it has to be 3, and 3 is prime, yeah? Okay, what else? What other
Allowed,
questions?
right?
Say again, Lucas?
Repeats are allowed, right?
Yeah, definitely.
What's that scribbled number like?
That's a 6.
Yeah, but what
Okay,
does 6 go with? Yeah, but those bottoms. Oh,
that's not on the chessboard. That's not on the board, yeah. Okay, so you have to check that every pair of numbers that a knight can move from has to be prime ratio, yeah? But what else? There has to be a 5 and a 6 somewhere, yeah? Okay, so we can see there's a 6 here and there's like a 5 there, yeah?
Yeah.
Okay, what else?
There's 6.
Yeah, so at the moment it seems Caleb uses only 2s, 6s, 5s, 1s, and 3s, yeah? So that's not that many numbers. Okay. So Caleb just uses 1, 2, 3, 5, and 6, yeah? Alright. So can you explain to us why, like, all the pairs of squares have prime ratio? Why is that? Can you explain it?
Because it's like a 1. It's surrounded by 3. It's that 1. It's surrounded by 6. If a 9 moves, it would go to 3, 3. Go to 3.
Yeah.
So 3 divided by 1 is 3. So the ratio. So 3 is a prime number.
Yeah. So are you asking us to check 300 things? Is that what you're saying? Huh? I mean, you can check 300 things, yeah? It's like, it's not beyond us to do so, yeah? But, I mean, there must have been a reason you put all the ones like that, yeah? Okay, so what do we have to check, people? So look, if you have the numbers 1, 2, 3, 5, 6, yeah? 3. So you look at these numbers, yeah? So like, if 1 goes with 2, yeah? You don't have any issues, yeah? If 1 goes with 3, you don't have any issues, yeah? 1 goes with 5, you don't have any issues, yeah? But what do you have issues with?
1 going with 6.
It's a trick question. So yeah, you have issues with 1 going with 6. Is that it?
1 going with itself.
Yeah, there we go. See? The outside possibility, yeah? So 1 could also go with itself, yeah? What's the ratio of 1 and 1?
1.
And is it prime?
So nothing.
No, it's not prime.
1 is not a prime, right? So 1 cannot go with 1, and it cannot go with 6, right?
So none of the numbers can go with themselves. None of the numbers can go with themselves.
Yeah, so none of the numbers can go with themselves because the ratio will be 1, right? Okay. So you got to be aware of that, yeah? So the logic requires you to think of all the possibilities, not just the obvious ones, okay? Alright. So having said that, 6, what can 6 go with?
2 and 3.
6 can go with 2 and 3, yeah? Okay. Alright. And then, okay, what can't 3 go with?
2, 5, and 6.
3 can't go with 2, 5, or 6, or 3, yeah? Okay. So we're in business here, okay? So there's only 1, 2, 3, 4 6s, yeah? And we can literally just check what the 6s can move to, yeah? There's only 4 of them. So this 6 can only go to 3 and 3, which gives you 2, right? Yeah. This 6 gives you 2 and 2 and 2, which gives you 3. And you have another 6, yeah, which goes to... Wait, what number is this?
That's a 5.
So does this 6 go with the 5?
That's a 1.
That's a 1.
Yeah.
That's a 1.
That's like that.
So where's the other 6? It's here and here, yeah?
And the one on the bottom one.
And here, yeah?
Yes. There are 2 on the bottom.
Yeah. Okay. And then 5s you can check as well, separately. Okay. Okay, how do we know 1s don't go with 1? There's so many 1s, we have to check them all.
Is it like diagonal to each other, then they can be like a circle?
Yeah. Okay, so there's this nice thing in chess. Okay, if you do chess, so what does chess mean? So chess means like, so you take this grid, right? So what does chess mean? Chess means like you color the grid like black and white squares, right?
Yeah.
So that's black, and that's black. Yeah?
Yeah.
So you see if like a knight starts If knight starts on a black square, right?
Yeah, it has to go.
It can't go to a black square,
It has to go to a
right? It has to go to a white square because if it goes down 2, it gets to the same color square, right? And when it moves 1, it changes color. Okay. So if you color the board black and white, no two numbers on the same color can ever hit each other. Okay. So if you look at here, all the ones are on the same color. Yeah. So if you think of this as like black, and this is black, that's black, then the ones go along here, right? And they stay black. Okay. Yeah. So I guess your solution could work. Okay. And it's really good that you found it. Okay. It's not a. So this is not an easy problem for your age. Okay. So, but when you do find it, you want to find like the best one. Does that make sense? And the best one is the one that we'll appreciate more because we don't have to check 300 things. Okay. So let me show you. Let me show you an example. Okay, so I don't know if you guys remember Ben Chen. I think owners remember Ben Chen.
I remember him.
Okay. There was another student that used to be here. Beecroft. Yeah. So look at this solution, okay? Ben Chen. So it's much nicer because it's so simple, okay? It literally only has ones and twos, okay? And it has 1 5 in the corner, and it has 1 6 over here, okay? And you can see right away this 5 can only move to a 1 or a 1, yeah? And this 6 could actually also be in the corner, but this 6 right here, it can move to 2, 2, 2, or 2, right? So that means the 6 and the 5 are okay. You just need to check the 2 and the 1s, yeah? But the 1s are all on the black squares, you see? And the 2s are all on the white squares, yeah? So a 2 can never meet with a 2. And a 1 can never meet with a 1.
Yeah.
So that means every ratio you get must be a prime. Okay? And that's kind of the beauty of this solution, is that it's so simple. Yeah? Okay? And that's definitely not the first thing you think of. Okay? But, with some skill, it could be. You guys understand that?
Yeah.
So, I don't know, like this kind of thing.
That 6 could switch with the 1.
Which one?
6 could switch to
6 could switch to the 1 next to the 5. Yeah, exactly. It could be literally anywhere.
Except
Right.
for the 2 1 5 is
It could
occupied.
like almost
Yeah.
it can switch with almost any one. The 6 could be swapped with any of the 1 except for the ones that are connected.
Yeah, exactly. Okay, you see why is that? Because all the ones are not connected with the other ones, right? They're only connected with 2s or 5s. Yeah. So as long as you avoid the 5, the 6 is fine. Yeah. Yeah. But you can see it's not like we're not necessarily interested in grids and numbering grids, right? We're interested in the fact that we're given some conditions and we can actually satisfy it. Yeah. So, and there's a notion of right and wrong. Okay. Okay, so it's gonna get harder from here, okay? But I'm gonna guide you so it's not gonna be as bad. Alright? So remember, let's see how you go. And if you really get hungry or something, let me know, okay? Okay. it doesn't apply to her because she's obviously not doing anything productive. Why are you on the ground? Can you get back on the seat or go somewhere else? I think. Okay, have a look at the second question, okay? Okay, so we need to understand this question. So if you don't understand the question, we should take some moments to ask questions about it. Okay, and you'll see that when you don't understand something, those kind of questions are probably the same for everyone. It's just some people eventually end up just asking themselves. Okay? Do you understand the question? Question 2.
Wait, so can it be any like square?
So you're asking what does unit square mean, right? So if it just said a square paper, then that's any square, right? But it said a unit square. So what does the word unit mean then? Yeah, that's what the word means. But like, what does a unit in this context square mean?
1 by 1 square?
Yeah. So it just means that it's one, like the side length is 1. Yeah.
Can it be any 1 by 1 square?
So unit as in 1, like the unit digit of a number. Yeah. That's the ones digit. Yeah.
Is it like the area of a six of a paper?
Yeah. Wait, but like,
Yeah.
can
So the
it be
question.
any?
A six of the
1 by 1
normal
square?
paper or the ones whole?
With the whole. So it's like this.
Can it be any?
Its question is like. So it's very strange, right? You probably haven't seen a question like this before. It actually tells you the answer. It just wants you to explain why it's true. Okay. So you have a square. Yeah. And it says no matter what triangle you cut. So you suppose you just like take a knife and stab a triangle like this. Yeah.
Right?
Oh, okay. That can't happen because that went outside. You're not allowed to go outside. Okay. So you take a triangle and you cut it. Yeah. And that gets deleted. Yeah. And the question is, no matter where you draw this triangle, as long as those 3 points don't touch the sides of the square, can you show that there's always like another triangle like in the remaining paper that has area 1 on 6? That make sense?
Can the triangle have the hole in it?
No, the hole can't be like over here. Like that won't work then, yeah? You can't the triangle needs to be like a proper triangle. It's not allowed to go through the hole. Yeah? So maybe there's one here. Okay, so no matter where you draw the hole, you can always find a big enough triangle. Okay?
What if it's a triangle that like is a millimeter away from the side, so it's like very big?
Say again.
What if it's like a triangle almost touches but doesn't touch like the edge of the paper?
Yeah, you're allowed to do that, yeah. So essentially, I guess the main problem is if your triangle's big, right?
Yeah.
So if you want a big triangle hole, can you still cut out 1/6 out of the remaining parts?
Maybe it's because when the triangle is cut out, the sides will still be. This is our main area. Close to the Wait, but then like you said right in the triangle like a six. But then isn't this? Oh yeah, that's correct. But then, wait, that means you can make it smaller. We don't know how much it takes to but we know we can because we could help out with it. So like, this is like a half. But then there's the other half, which is a six. So it's one quarter. That's exactly. Does it have to be like exactly 1/6 or 1/6 or more?
I mean, if you can get a 1/6 or more, then you can also just trim it off to get it to be exactly 1/6.
Oh yes. Wait, a 6 of the original square paper, or a six.
Oh no, like because the area of the square is 1, right? Because 1 times 1.
Yeah.
Yeah. You want something with area 1/6.
Oh.
Yeah, so it is 1/6. It is 1/6 of the area of the square because the square has area 1. Yeah.
Yes.
No, it's saying prove that you can do it. So it's telling you that it's possible, but can you explain why it's possible?
So is it like 1/6 of the remaining paper?
Yeah, like so the 1/6 of the original square, yeah, that area, cut from the remaining paper. That makes sense.
What do you mean by prove it? Prove it as in like write an explanation.
Yeah, like what? Like is it like at the moment, right? When you see that, you don't even know if it's true or not, right? So what I mean by proof is like, in the most extreme, like perfect proof, yeah, is once you've told me your proof, I would bet my life on it being true based on what you told me. Okay, that's like the most extreme, you know? But then obviously I could be less than that. I could be like, oh, I'm just very convinced that it's true. You know what I mean? So in maths, that's what rigor is. It's meant to be your absolutely certain. Okay? Whereas the opposite of a proof at the moment is we don't know at all if it's even true. Okay? This one. What is it that you're saying?
As in, this is the triangle out, and then that's the remaining area on the paper.
Okay.
And then, like a 6 of that.
Oh, okay. Well, that proves something. Okay, so that proves that it can be done with this particular hole, right? So for what we want to show, it can be done no matter what the hole is. That makes sense. So you've shown me that it can be done with this hole, which is good. Okay, that's a start. You know, how do you know it will work if I'll change the hole to make some weird triangle? You know?
It's like this big. This is like a string.
What do you mean?
This is like a hole. This is a hole, so you can like trim it.
Yeah, if that's the case. Yeah. But it might not be, right? The thing could be in your way.
This happens when.
Huh?
What if this happens? Like,
Yeah, so this is like a test of your like arguing skills because a lot of people say, "Oh, you can do this and this," but then it's like it doesn't apply to all the cases.
if you do this, then you do that. But isn't it just that as long as you don't use the corner doesn't touch the border of the paper,
Yeah.
then you can always be able to do it. Like isn't that just common logic? Because then you can just divide the remaining area by 6. And
I don't know, like so you don't have control over where the hole is, you know? So the problem is like no matter where the hole is, yeah.
Yeah, no matter where the hole is.
Find
Like
an area of a 6.
Oh,
But we're thinking like big triangles.
oh wait, no matter where the hole is.
Yeah, but
Why don't you just do this? Yeah, but that's touching. And anyways, it's like almost touching. Almost. Yeah, but what? Oh. This would be like a quarter. No. Because this would take up First of all, this one. No, go. Isn't that?
你在干嘛？为什么不听课？嗯，坐着听课。
Okay, I'll draw a better square. I got to do a better circle. Wait, let me. Okay, screwed up here. This like a scaling triangle. Okay, but then he would do. So what if you did that? Like, yeah, so like, okay. And then,
Look at that sound show.
Show it again.
so that this what was good up. Because possible.
你可以起来吗？你为什么在这儿？
Yeah. But then, no matter what, they'll always do it easy. No, not necessarily. No. Let's draw the leaders. The leaders is triangle. And this is do that again. Like for example, they're like that's watching the actually. And then like very close to the oh yeah, it is.
This square is 24 squares and half a square.
Oh, because
half
it's
a square.
3 points.
So all the halves
No.
equal to 2, and then these 2 squares equal to 2 squares, 2 squares equals 4, and 1/6 of 24 equals to 4. So this is right.
Well, can you find a triangle with area 4 outside of that?
Well, like, if you like, you can't, if you change one side, if it's like this, then if you change like a side to here, then this side would like allow a bigger area, right?
Yeah.
So, it is technically impossible. So, like this. Now you draw me a triangle.
Wait, what do I have to put?
You have to prove that in the paper that's left, you can find a triangle with area 1/6.
On the paper that's left.
Yeah.
Use that triangle this way, and I can prove it on.
Wait, so the triangle has the area of 1/6. Wait, so is it? the remaining paper that has this is the paper that's cut that has area of 1/6 of the other paper, like the remaining paper off of the cut that's supposed to be 1/6. Which one? Is the triangle the whole of the triangle area supposed to be 1/6?
Yeah, the area of the triangle that you're trying to get after. So you gotta square.
Yeah.
And you cut a hole out, yeah?
Yeah.
And then after you cut the hole out, you want a triangle from the remaining paper that has an area of 6.
Hello?
Hi Aiden, so we're doing question number 2.
Yeah.
We're about to just look through the solution now, okay? Yeah, so I think the thing is, these problems are very nice and they take a long time to solve, and I'm not giving you enough time, right? But if I
Yeah.
gave you enough time, we could spend the whole lesson on the first question even. You know what I'm saying?
Yeah.
We could spend the whole lesson on the second question. So I want to give people an idea of what these questions are like, and if you're really interested, you can look at some of them at home. Okay. Okay. So for question 2, it's a very kind of simple question statement, right? Yeah. It's a question anyone can understand. Yeah.
I know it's true. I just kind of.
But it's very tricky to explain, right? Does that make sense?
No, it's true. It says proof.
Yeah, it actually even tells you it's true, right? But if you're not sure it's true, then you're not gonna have a very good time proving it. And if you are sure it's true, maybe you're not as sure as a proof would suggest that you should be sure it's true. Okay? So remember, like a proof is like, I'll bet my life on this being true. Okay? Not just, oh yeah, it probably is true. Yeah? It's like a very different, and you actually learn about like logical reasoning and proofs in debating as well. You know? So okay, so what makes a proof? Well, so logic, for some reason, it has to happen in steps. We're not very good at dealing with like a continuous flow of logic. Does that make sense? We like one sentence at a time. Yeah, we can't just keep talking non-stop. Yeah, so if we can break it up into like step by step, then that will add to our certainty. Okay, so if we can string it into things that we're sure of, then we can be sure of the whole thing, and that's called a proof. Okay, your understanding of a proof will evolve as time goes on. So most of the time when you're in primary school, when you do maths, it's like who can get the answer the fastest, you know, who can say they understand it when someone explains it. That's like what people thought was being good at maths, right? When you get older and you learn about proof, you'll see that actually getting the answer fast is not actually valuable unless you're sure it's right. Okay, being sure is actually more important than the speed. And people who think they get something might only think they get it because they had a lower standard of proof to get something. Okay? Now, if we have... let's have a look at one of the students' diagrams, which was pretty good. Okay, let me just enlarge this. Right, sorry, I don't know, is it lagging or let me just let me put it on the screen for a second. Maybe cool. Okay, let's focus on this diagram if we can. It'd be good if I could zoom in on it, but hopefully we don't need to zoom in that much, okay? So like you'll probably notice that when you do it, you're like, oh yeah, I can see if I just get some random triangle, then I can probably cut like a sixth out of the remaining, right? But but so that's kind of convincing, but it might not be like absolute certainty because you don't know like what kind of triangles you could actually draw. That's really weird, right? So here's maybe a nice way to explain it. You see, this comes under maths, but you're really just explaining something we all sort of have like this common understanding, right? Okay, so let's see what this student does. So look what they do, okay? They draw the square, okay? And then they draw you know what the midpoint is? So the halfway between the corners, yeah? And they also draw the trisection points, which is like a third of the way, yeah? So here's a third and here's 2/3, yeah? So they draw 3 points on every side, yeah? Okay. And then they join points strategically, okay? So for example, they join this point, not don't touch the table, okay? So they join this point to this point, yeah? And the reason they do that is if you complete this triangle with the sides of the square, right? So that triangle. Can you tell me what area the triangle has? A 6, yeah? Yeah, it's a base times height, yeah? Divided by 2. So that's 1/3 times 1 divided by 2 is a 6, yeah? Okay, so they do that all these lines, yeah? Okay. So now there's an interesting thing is if I'm gonna cut a hole into the square, yeah? Okay. So if I cut a hole into the square like this, yeah? Right? Let's assume that this didn't go out. I was just drawing it bad. Okay. If this blue hole misses that red triangle, yeah? Then that red triangle could just be my answer, right? Could be the thing I'm looking for. Does that make sense? Okay. So for my hole to not so for my proof to not work, right? I'm trying to come up with a blue hole that cuts into this triangle. Yeah? So then I can't use this triangle to be the demonstration. Yeah? Okay. So what does that require? It actually requires one of the points of the triangles to actually be inside this red triangle. Yeah? Does that make sense? So if a corner of the blue triangle is inside the red triangle, then we can't use this red triangle to show that it has a 1/6 left over. Yeah? But otherwise we can. Yeah? So this actually leads to a very interesting argument. So let me just erase this. So let me just draw that red triangle again, yeah? Okay. Now, what if I draw another red triangle here? So I join the half to the third, yeah? Okay, that's one of the lines that was drawn, okay? So why was that line special, do you remember? Okay, sorry, that triangle is getting really bad. Okay. So do you know the area of this triangle here? 2. So what's the area of this triangle? So you got the midpoint here, up to A, and going 2/3 along, and then like that. Yeah. What's the area of that triangle? Yeah. Why is it 1/6?
Because it's more like
Yeah, because base times height again, right? So you have 2/3 times 1/2. Yeah. What's 2/3 times 1/2? What's 2/3 times 1/2? What's 2/3 times 1/2? Yeah, half of 2 of something is just 1 of something. Yeah. So there's 1/3. Okay. So, and then half of 1/3 is a 6th, right? And that's the area of a triangle. Okay. Okay, let me do one more. Let me draw this triangle here.
Six. That's the same. That's the same area as the first one. See, that's one.
That's the same as that one, right? So this is 1 times a third divided by 2. So it's a 6th. Yeah? So can you see what I've done here? I've got 3 triangles that basically don't overlap. Yeah? Okay. And so the thing is, if I had to cut a hole, I have to cut a hole that goes through each one, or I can just use them to get me a triangle of 1/6. Yeah? That was. So for example, there has to be a dot somewhere in there. There has to be a dot somewhere in there. There has to be a dot somewhere in there, right? So it kind of forces me to cut my hole in a certain way. Can you see that? And so it kind of allows me to argue more directly, yeah? Because before, the main problem is you kind of don't know what the hole is. So when you're talking about it, you don't know what you're talking about, right? But now we're talking about a hole where the points are within these red triangles, yeah? Okay. Okay, now let me draw another red triangle. Yeah, so by the way, this is getting to the 2-hour mark, okay? So if you're tired, it's kind of normal. You guys, you're losing it, right? Mentally. I don't know if you ever had it, but it's getting tiring.
I already did so much math at school.
Oh.
I didn't do math at school at all.
Today?
Yeah.
Oh.
Well, it's because math was so hard.
Yeah, it was.
I did a math review.
Can I bring up something that I thought of?
Yeah.
It's because we only learned
Technically, if we find out
Are you
how
allergic to
much
anything?
area the biggest triangle can cut out of the square, then doesn't that mean we can prove that we can cut 1/6 of it out?
Lucas, what did you say?
If we figure out how much the triangle, like, say we take the biggest triangle inside the square, and then we cut that out.
Yeah.
What's left is going to be bigger than 1/6.
Yeah. I mean,
just proof out that or whatever.
I mean that would work if the notion of biggest triangle made sense, yeah. So you'd have to define what biggest triangle meant.
Biggest triangle.
Yeah, because there could be lots of biggest triangles, right?
Biggest triangle is just the most amount of area a triangle can put out of that square.
Where you go? Out. Go on. Okay, so watch this. If I were to draw another triangle, yeah, so having a bit of a drink might help with your concentration after a certain point. Alright, so you can probably hold up. You might need it a bit more than you right now. Okay, so let me just draw another triangle, okay? I could draw it pretty much anywhere, but alright, how about you guys tell me where to draw the triangle? So I'm allowed to overlap now, okay? Because I've already got 3, yeah?
One like the one opposite the one that's the one in the bottom right corner. Yeah, bottom right.
So like this point here, there.
The one that's like the one at point A. No, it can't be that one as well.
Okay, you want this one? Is that what you're saying? Yeah. Okay. So if I draw that one, okay, can you see if I draw that one? It gives me 2 options, right? I need to have a blue dot inside that triangle, right? So can you see what my 2 options are?
At the line, black line.
What?
Right. Where they overlap?
Where they overlap, like here.
Yeah.
What about it? Yeah, so I mean the main issue is we need a blue dot inside this new red triangle, yeah? And so we have 2 choices we can do, yeah? We can either move this blue dot in there, or we can move that blue dot in there. That make sense? Okay. So let's pick one of those to do, and then let's see that we can actually do it properly. And then hopefully that'll convince you can just do the same thing with the other one. Okay? So which one do you want to pick? Left one or right one? Left? Okay, left.
If you move one, I will just give you another possibility.
Okay, suppose you move that one, yeah? And now the dot is somewhere in here. Yeah? Does that make sense?
Yeah.
The dot is somewhere in there. Yeah? Okay, so... But I guess the point is, it's within... It's within, like, that bottom bit, yeah? Okay. So let's have a look. If it's within that bottom bit, can we say anything else? Can we do something else? you know, I guess we can draw like lots of triangles here as well. Like we can draw a triangle like here. Here. And so it's not just within the whole bottom bit, it's actually within this little bit here. Yeah? That makes sense? So it's within this little bit here. And that means it's not inside this triangle, for example, that we draw here. Right? Okay.
Wait, so how do you put the dot at the three, like, where those two triangles? The one with the green one. Yeah,
Here. Remember, you can't put it on the edge of the square. That's part of the rules.
Oh.
Yeah. So it would have been a problem if you could put it on there, right? Then this one would still satisfy. But because this one can't, it's already on the other side, it has to be that one which comes in to help, right? So now you have that one trapped inside this smaller area here. Yeah? It's actually going along this line, I think. Yeah. Okay. And this one's trapped there. And so basically the idea is you can keep doing, like each step is like conclusive, yeah? There's not like any hand waving. There's more, it's just like if I draw this triangle, then this dot has to be within here, yeah? So these are like, these steps are sure things, yeah? There's nothing vague about them. Okay, so let's keep going. How can we keep going? Can we try to restrict, I guess this dot any further? Yeah. So at the moment, let me put the blue dots in. Let me put them in purple. So we have some purple thing here. Have some purple thing here. Now we have some purple thing in there. Yeah. Okay. You see?
Yeah.
What do you see?
That would make it increase the noise. But since it's a triangle and not a square, we'll be able to do all the
Mm-hmm. Yeah, so what you can do, right, is like what makes this argument move is that like because anytime there's a triangle of area 1/6 that doesn't have any dots in it, then that's something that would finish the argument, right? So every time you have that, the dots would have to sort of move so that that triangle had the dot inside it. You know? Okay, so let me give you an example. So if I drew this triangle here, okay, it's not very straight. Okay, let me just draw with a pen, it'll be better. Okay. Green, Doesn't seem to be working. Okay, so if I bring this back up, yeah, that should be a bit better, right? Alright, where were we? What were those triangles, you remember? It was like that one, right? What are we doing? The 6? Like that, yeah. And like this. What was the other one? Yeah. From where?
Yeah, the
Yeah.
No, like on the side.
one side.
Yeah.
Yeah, that one.
Like that. Yeah.
Yeah.
Okay. And okay, let's just say we had the blue things. So something in here and something in here and then something in here, right? And so then when we draw the bottom right one of the blue things has to move into it, right?
Yeah.
So let's say you said it was, let's say it's this one, yeah? It moves into it, yeah? So it has to go inside here. Okay. Okay, and then we also drew, maybe we drew this triangle here. And so it actually ends up, it has to be in here. Yeah, it has to be in this little green rectangle, right triangle. Yeah, there's another green triangle over here, yeah? Okay, which forces this blue thing in here. Yeah? Okay, good. And okay, so then you could draw like another triangle maybe over here. Yeah? Yeah, so either force you to move the green one up or the blue one up. Which one do you want to move?
The blue one would actually be better for the person who's
To move the blue one up?
Yeah, for the person who's cutting the holes.
Okay, so let's try to move the blue one up here. Say there, yeah? Okay. Okay, so if the blue one moved up, can you see now we can start concluding stuff, okay? Because now the blue one's moved up, yeah? It's now out of the way of all these triangles now. So if I make this triangle here, you see that has an area of a 6, right? So because that is out of the way now, the only thing that can go into that is this blue dot, right?
Mm-hmm.
So this blue dot has to move into there, okay? And so the point is now that blue dot is really out of the way now.
Yeah.
Okay? So if the blue dot's really out of the way, then it can't get in the way of like this triangle here. See what I'm saying? So I make this triangle here.
You should move the green dot.
I have to move the green dot all the way down, right? So the green dot has to move all the way down into that triangle. Yeah? You see that? Okay.
No, it has to move like into the other triangle.
So it has to move into, yeah, it has to stay in its triangle, right? So it has to stay in, yeah, Ernest is very observant. That's good. So it has to stay in this triangle, yeah? Okay. But can you see now that it's moved out of the way like that, there's, it can't go into this triangle anymore, right? For example, yeah? Then you have to move the purple one from there into the green triangle. It has to be inside this triangle. You see? Okay. But once you move the purple one in there, there's nothing over here now. Yeah, I'll do it in orange. See that? Yeah. And there's nothing you can move there. Yeah. So that, can you see that's like, that completes the proof. Yeah. Okay. So what's the difference between what I just did and a full proof?
It's easier to explain because you can actually like draw it while you're explaining it to the people instead of like drawing the complete diagram and putting a proof. It'll be like easier to understand if you're the one actually talking and draw each line like when you're talking so they know which line you're talking about.
Sure. I mean, so but in principle it's the same. Okay. If I say it or if I write it, like the fact it's a proof shouldn't depend on if I'm saying it or if I'm writing it. Okay. So yeah, like it'll be much harder to write down than I'm making it seem by just saying it, right? But I'm talking about like, have I covered all the possibilities? Like, what am I missing from this proof? So with the proof, okay, I have to take care of all the cases, okay? So at some point, like at the very start, I could have moved that blue dot or I could have moved the other blue dot, right? And I only examine what happened when we moved the left blue dot, yeah? Okay? But we also need to know what happens when we move the right blue dot, okay? And what I'm trying to say is, it should be more or less the same kind of argument, yeah? It's just doing it again. So this is like a proof of concept, yeah? Even though I didn't give you the full proof, I'm showing you I can actually get to a conclusion in a way that you can be really sure of. See? Like, there was no doubt that, like, when we put the triangle here, that dot had to move within the green triangle. You know what I mean? That was completely solid. Okay, and in the end, we got this orange triangle, which had nothing to do, so therefore you can cut that orange triangle in the end. Yeah? Okay, very good. What's going on? See? Like, there was no doubt that, like, the triangle here, that dot had to move. Yeah, sorry. So basically, if you missed the class, you can still see it on replay. Alright, so does that make sense? Yeah? So we're kind of just playing this game where we're drawing lots of triangles and we force, so then no matter where you put the blue dots, you can always find like this orange triangle that has area 1/6. Yeah?
Yeah.
And putting the blue dots is the same as placing the triangle hole. Okay? Do you understand that?
Yeah.
That's not actually easy to understand, okay, but I think it's interesting, right? Because we're not talking magic, right? We're talking about triangles and squares. We're talking about things we all understand. Yeah? We're not particularly fond of triangles and squares. They're just simple enough to talk about. Yeah? Okay. Alright, 6. Okay, so we're really getting to the harder stuff now. See how much your brain can last.
On the sheet it says question 3. let us call pi squared. Yeah, pi squared called 2 times pi squared. So your one just says let's call 2 times pi squared.
Oh, there's some edits. Alright, don't worry about that too much. Okay, so this question, I'm not gonna give you too much time to think about it, but I'm gonna try to explain it to you and kind of hopefully you can appreciate. So basically, this question is asking you have these essentially dominoes, okay? And the condition is like this number below is always bigger than the number above, and they're always like counting numbers, okay? Yeah. So you have lots of numbers like this. Hello? Michael, can you finish? 他可以继续吗？他可以还可以继续多久吗？可以再继续会儿，还有多长时间？我再问一下。其实本来就是到他注意力还不错的。他这个3点先到几点啊？可以到6点一刻吗？6点一刻可以没问题。好，那接下来把这个乳先审查。好。Alright, Caleb has to go in like 8 minutes. Let me try to explain this in 8 minutes. Okay, so you got these dominoes with 1s and 5s and 2s and 8s, and as long as the first number is smaller than the second number, and they can't have 0, okay? And you're allowed to move from one domino to another by adding the same number to both the top and bottom, or dividing the top and bottom by the same number, or timesing. Yeah, adding, subtracting, timesing, as long as it stays with the same rules. Yeah. So, for example, you're not allowed to do -2 because that'll leave you with 6 and 0. Yeah. You can't do that. Yeah. But you are allowed to do -1 because that'll leave you 1 and 7. Yeah. Okay. And the question is it possible to get from... So one instance of the question is it possible to get from any domino to any other domino in just 2 moves? Okay. Is it possible to do it in 3 moves? Is it possible to do it in 4 moves, 5 moves? Can it even always be done, right? Okay. So it's pretty crazy. Okay, so let me show you, okay, that it's impossible to get from 1-5 to 2-8 in less than 3 moves. So it can't be done in 2 moves. Does that make sense? Okay, so 1-5. So to get from 1-5 anywhere, okay, 1's already the lowest number, yeah? So you can't subtract, yeah? You can't divide either, yeah? So you have to times or you have to plus, yeah? Okay. So let's say if you times by 2, for example. If you times by 2,
She was eating those and she's making loud sounds.
Oh, don't make noise. Okay, so 1-5. If you times by 2, right? You get 2-10. Yeah? Okay. But you can't get from 2-10 to 2-8 in 1 move. Yeah? Because anything you do to the 2, you have to do also to the 10. So 2 stays to 2, you have to keep it the same, but then the 10 won't stay 10 staying the same won't give you 8. Yeah? So you can't multiply by 2. If you add by 1, okay, you get 2-6. Yeah? And you can't get from 2-6 to 2-8 in 1 move. Okay, because the 2's are the same, so you can't add anything, and you can't times anything, or they would change, right? And if you didn't change the 6, it would never turn into the 8. Okay. And if you multiplied or added anything else, it'd be bigger than the 2, right? So then you'd have to subtract or divide. Yeah. So the only two possible things you can do is times and then subtract, okay, or plus then divide. That's the only two moves you can do if you can get it in 2 moves. Does that make sense?
Yeah.
Do you agree? Okay. If those are the only 2 moves you can do, okay. So how does the first one work? So how does it work if you times and then subtract, yeah? So to be able to subtract and get the number, you have to have the difference between the numbers be the same. Does that make sense? Like 2 and 8. No matter what I add or subtract, the numbers will have the same difference of 6. Does that make sense? So this is a difference of 6. If I add like 2, I get 4 and 10, right? It's still a difference of 6. Yeah? So that means, so currently 1 and 5 has a difference of 4. Yeah?
Like, what is the square?
Huh?
The square is
No, you can't square numbers. You can only add. So the difference of 4 and the difference of 6. Yeah?
Yeah.
So there's no way to change 4 to 6 by multiplying. Yeah? That makes sense? Okay, because the reason is if you multiply a difference of 4, you'll get a multiple of 4. Yeah? And the 6 is not a multiple of 4. Yeah? But you had to have been able to do that for subtracting to get you to 2/8. Okay? So therefore you can't do times and minus. Okay? You have to do plus and divide. Okay? But we have the same problem with plus and divide, because when you plus, the difference stays the same. Yeah? So when you add something to 1/5, it's still going to have a difference of 4. Okay? And then, so you have to divide by something to get a difference of 4 to turn into a difference of 6. Okay? But if you divide, the difference just divides. Okay? So if you divide by 2, okay, then the difference just divides by 2. That makes sense? Yeah? Even though you're not actually allowed to divide like 1/5 by 2, yeah? But the point is, even if you could, you couldn't turn 4 into 6, right? Oh yeah, Lucas, what do you want? Do you have a question?
No.
Hello?
For the divide, can't you just no, for the add, can't you just add by the difference and then divide by the total number?
You add by the difference and divide by the top number?
And then you're left with 1 and 2.
What do you mean? So you have...
Actually, hold on.
So you're saying, are we talking about 1/5 still?
No.
Are we talking about this example or something else? Lucas?
Hold on.
Okay, yeah, Lucas, I'll get back to you, okay? But I just gotta finish this line of thought. So we see if we add and then divide, yeah, we need to get a difference of 4 to turn into a difference of 6, yeah. Okay, but we can only divide. Yeah, so we can only divide by things which divide the difference, okay, to get a whole number in the end. So if we divide by 4 or 2 or 1, we're only going to get a smaller difference. We're not going to get a difference of 6. Yeah? So it's actually impossible to get from 1, 5 to 2, 8 in 2 steps. Okay. I'll quickly show how you can do it in 3 steps. Okay, and then I think Caleb will have to go. Okay, so if I start with 1, 5, yeah.
Yeah.
So it's kind of nice. What I can do is I can do I can take the difference of 1 and 5 is 4. Yeah. And I can difference of 2 and 8 is 6. Yeah. And then what I can do is I can take the lowest common multiple of these two numbers, which is what? Lowest common multiple. You know what lowest common multiple is? 12, yeah? Okay. Yeah, so okay, and then I do 12 divided by 4, which is 3, yeah? And 12 divided by 6, which is 2, yeah? Okay, so what I'm doing is I'm timesing this by 2 to get 4, 16, yeah? Okay. And I'm timesing this by 3 to get 3, 15, yeah? Okay. What do you notice about 315 and 416? Very good. Okay, so they have the same difference of 12, yeah? Which means, so what does that mean that they have the same difference? What can you do?
Add or subtract.
Yeah, you could just, so in this case you just subtract or add 1, right?
Yeah.
So if you add 1 here, you get to that, right? So then to get from 1, 5 to 2, 8 in 3 steps, what you do is you times it by 3, yeah? You add 1, right? And then you divide it by 2. Yeah? That's pretty cool, right? Yeah.
Can I have like another?
Sure. Yeah.
I haven't used this
Alright.
one.
Is that unused?
Yeah, I haven't used it.
You touched it though, so. I think it's good not have.
Yes, this is some chips.
Alright, so we farewell Caleb. Caleb, thanks for coming.
6. 6. Yeah, there's 6. There's not 7. Yes, 7.
Yes,
7.
yeah. That's what you must have. You know how it's number 1. Okay, so my question is, if you switch the numbers, could you still do it? So now that he's gone, yeah, sure. So I'll leave this question up. What if you had like 2, 3, yeah, and like 100, 200, yeah? Could you get from that to that in 3 steps? Did I give you a water?
Yes.
Oh, okay, good. Okay, I'm getting like dementia or something. Wow, very good. And what two steps are those?
Times 100 and then minus 1.
Yeah, very good. Okay, times 100. So if you times 100, you get to 200, 300, right? And then you minus 100, you get to 100, 200. Very good. Yeah. So this question, can you believe that in all of Australia only one person solved, okay? And it was a girl in year 8. And she proved that no matter what, okay, no matter what two dominoes you have, you can always get one to the other in at most 3 steps. Okay? No matter what the numbers. Okay? And if and it was impossible to get everything in 2 steps because it was impossible to get from 1 5 to 2 8 in 2 steps. You know? So 3 was the minimum that you could expect everything to be able to be gotten from anything else. Okay, maybe you can come up with a random number and I'll kind of show you. But so name 4 random numbers.
36.
Okay, 36.
7.
7.
4.
4.
2.
This is not very random. Why are all the random numbers less than 40?
I want to change mine.
Yours is the most random.
I want to change mine.
To what?
69.
I don't know, what is this?
What is wrong with you, Michelle?
Because the boys always talk about it, so maybe I should just do 69.
I think I need a recess.
How dare you?
137.
What did Lucas say?
137.
I like 137 better than 4. Okay. Actually, we'll stick with 36 because Michelle doesn't really deserve to have this kind of. And 2 and.
Yeah, I kind of like 36 better. Because I don't want to do the ones that boys talk about.
Okay, so how do we get from 736 to 2137? Can we do that? And that's one of the things I think when you're young and doing maths, not to think about the questions too abstractly. Try to think about actual examples. Okay.
That 37 or 137?
127.
Oh, 127.
137.
140.
Oh, okay.
237.
Is it 272?
247?
Shall stop talking.
What is it?
I said 137.
Oh, 137.
Can you use decimal?
No decimals. What do you mean? They are decimals.
They just got this one.
They just have 0, 0, 0, dot 0, 0, 0.
Positive.
Decimal just means like base 10 really. But like, yeah, possibly.
Positive. That's happy.
That means it can't be 0 or negative.
Happiness. Happy is it? With positive, happy.
Yeah.
Or positive means you don't have COVID.
So, stop being dumb, okay?
Okay.
Oh yeah, sure. Alright, did anyone get it? No? Okay, so remember, like, we wanted to make the differences the same, remember that?
Yeah.
So what's the difference here?
29.
Oh, what's the difference here?
135.
135. Okay, so how can we get 29 and 135 to be the same? How can we get 29 and 135 to be the same?
That's 1 equals 2.
What? So you can't get the difference the same by adding, right?
4 and then add empty.
Okay, so if you times 4.
29 times 4.
So you gotta be careful because you can't add to the difference, right? Because when you
Oh.
yeah. But yeah, so you have to times, yeah. You understand, Michael? One of them has a difference of 29, the other one has a difference of 135. You want to multiply each of them by something so they have the same difference, huh? So what could you do? Okay, so can you see that? No. If I was to multiply, can you see if I multiply this by 135, yeah? Right? Can you see the difference would be 29 times 135? Yeah? Okay. And if I were to multiply this by 29, right? Then the difference would also be 29 times 135. You see that? Okay. So then if they have the same difference, then I can just add to get to the one from the other, right? So this would be 7 times 135, and this would be 36 times 135. And this would be 2 times 29, and this would be 137 times 29. Yeah. And which one's bigger? So can you see I can just subtract to get that, and then they would have the same difference. So maybe we could test that out, okay? So basically what we're saying is 736, you can times by 135, yeah? and then subtract by whatever that difference is, and then this one will give you the same answer, 137 times 21, and then you can divide by 29 to get the answer. Yeah.
Does it work in every single possibility?
Yeah, I think it does, because you can always times by the other difference. Yeah. And then the difference will be just the product of the differences. So what am I claiming here? What's 7 times 135, you know?
945.
That's pretty good. Let's see, so yeah, 945. And what's 2 times 29? 58. Okay, so what's 945 minus 58? Yeah, 887. So then what I'm saying is you can start with 7 and 36, right? And then you can times by 29 and then subtract 887 and then divide by 29, okay? And you should be able to get 137. 137. Yeah.
Times 29 minus 777 divided by 29.
Yeah. Sorry, times 135. Times 135. Wait, let me just erase everything. So I'm saying that if you got 2 what were the numbers again? It was like 36 and 7. Yeah, so I'm saying if you take 36 and 7 and you times it by 135 and then you subtract 887 and then you divide by 29, right? You get 137 and 2. Okay? Is that true? Hmm? So remember you said that 7 times 135 was 945, yeah? What's 36 times 137? That's not that easy. What's that? We'll turn it off. We'll turn it off. Okay, so we know that 7 goes to 2 under this, yeah? But the question is, does 137 go to 36?
You work out one way, then you can work out the other way.
So I guess what's 36 times 135 minus 887 divided by 29? Oh, except I guess to make it, we write divide by 29 like that. Because then we know we've got to do the other operations first. Hmm? Michael, what are you doing? What's 36 times 135?
36 times 135.
Yeah.
4,800.
4,800.
I got 492.
It should end in a 0, yeah? So it's the same as 18 times 270.
Oh, and never mind. I got 4860. 4860.
Okay.
I read a zero.
18 times 270.
My handwriting wasn't.
So it's the same as 540 times 9, yeah? 540 times 9. 540 times 9 is like 4,860. Is that what you got? Wait.
Yeah.
Alright, so that's 4,860. What's 4,860 minus 887, Michael?
3,900 and 73.
Okay. 3,973. And what's 3,973 divided by 29? It should be 137. But do you know how to check it's 137?
And check if 137 times 29 is 319.
Yeah. Because if you know what the answer should be, you can just times it, yeah? Dividing is harder than times. So what's 137 times 29? Four 11 0 minus 137. 4,000 minus 27. Yeah. So it works. Yeah. Okay. Okay, so can you imagine doing that for any two numbers? You just times them so they have the same difference and then you add. Yeah? Okay. Okay, very good. So for the last, we don't have that much time, but for the last 15 minutes, let's do an easier exercise from one of the harder questions, okay? So this is international level like
What's the difference between A level and O level?
A level is meant to be much harder. So like question 7 is meant to challenge like the best in the world kind of thing. Yeah. Whereas like
Why is this theme chess?
because it's from Russia. And all Russians know how to play chess. The Russian word for chess is like shak.
Shock?
Shakmati. Okay, so there's actually lots of nice things about 4 and 5 as well, but for our level right now, I think let's have a look at 6. Okay. So 7 is a question that no one in Australia solved. Okay, as far as I know so far. 6 is something that no one I can see has solved correctly, but someone has made good progress. Okay, so what is question 6 asking? So it's asking like, is it possible to cut a rectangular pancake? Yeah. Let's just ignore the n. Okay. Let's just say 4. Yeah. Is it possible to get a rectangular pancake? Yeah. Cut it 4 times like this. Yeah. Okay. And cut it 4 times like this. Yeah. Such that the areas here, when you round them, okay, you know what rounding is? You round them, you get the numbers 1 to 16. Okay. So what do I mean by this? So like, so imagine I got like a 2 by 2, yeah? I have the number 1 here, and I have like the number, say like, I don't know, like 1.5, yeah? I have the number like 1 here, the number like 2 here, yeah? If I times them together, I get 1, 2, 1.5, 3, yeah? When I round them, I get 1, 2, 2, 3, yeah? Which is not 1, 2, 3, 4, so that doesn't work, yeah? But if I want it to be 1, 2, 3, 4, maybe I could make this 2.5, yeah? So that's 2.5. Then what do I get? So that's 1 still. This is 1.5 still, which rounds to 2, yeah? And this is 2.5, which rounds to 3, yeah? And what's 2.5 times 1.5? So it's 1.5 times through 2.5. So you just halve this and add it, yeah? So 1.25 added to 2.5 is 3.75, yeah? Rounds to 4. Okay. So for 2 by 2, you can cut it so it has 1, 2, 3, 4 when you round it, okay? And the question asks you, how many cuts can you do so that you can still achieve this, okay? And it's actually pretty amazing that you can prove that if you get 5 cuts, it's impossible to do this, okay? But when we got 4 cuts, okay? So this is an exercise for us in the very last minute. See if we can do it, okay? So this is probably easy enough that you can do when you're tired. Ah. Oh, okay. So let me take you to this. Yeah. So someone has done this for 4 cuts, okay? And what they're saying is if we make the side lengths 27 28, 3 on 2, 63 on 32, 7 on 3, and this one is 3 on 2, 38 on 7, 44 on 7, 48 on 7, okay? Then we get the right numbers, yeah? So I already did a few of these for you to prove that I'm with you. So I don't think we have time to do all of them, but I did a few already. And the ones that I did show... So these are correct, okay? So this is 16, this is 15, this is 13, and this is 4, okay? And this is 14, this is 10, and this is 7, okay? So let's assume we've already done those, okay? Now let us see if we can check the other 9 things, okay? So maybe you can start, and if you're too slow, I'll start doing it. Yeah, so I think one way to get started, which is pretty nice, just kind of do the easy ones first, yeah? So you have 3 over 2 times 3 over 2, yeah? What's that? Do you know how to multiply fractions? Where did you learn that?
Um,
School teaches you how to multiply fractions?
I also went to pre-uni.
Oh, okay.
9/4 is
Mm-hmm. Yeah, so 9/4, which is like 2 and something, yeah? 2 1/4. So this is correct, and 2 1/4 rounds to what? 2. So that's 2, yeah? Okay, what else can we check? Like, do you know how to do, like 44 on 7 times 63 on 32? How to do that? Huh?
Yeah.
How?
Just multiply
Oh, okay.
44 and 63 and 7 times 32.
Oh, okay, yeah, I mean,
Or you could like simplify it.
okay, how would you do that? So 44 on 7 times 63 on 32, yeah? Okay, what are your steps? Oh, okay, so I would not recommend multiplying, you know? So, you see, like 7 goes into 63.
Oh,
Yeah, so
9.
yeah, so with fractions, try to divide as much as possible, yeah? So 7 goes into that as 9, and it's like already an easier question. That's not even a fraction anymore, yeah? Now what else can you do? Divide by 4, oh yeah, that's 11 times 9 on 8, yeah? What do you get? Yeah, this is much easier than actually timesing and then simplifying, right? Simplifying then timesing. So 99/8. What's 99/8? Oh, like what does it round to at least? Yeah, it rounds to 12. And what is it? So it's 12 and how many eighths? Michael, do you know how to do fractions? You should ask. Huh? Yeah, so this is equal to 96/8 plus 3/8. Yeah? So 96 is 12 lots of 8. Yeah? So 96 eighths is 12. And 12 plus 3/8 is, it rounds down to 12. Yeah? Okay, we have 5 minutes to do another 6 checks. Yeah? So less than a minute per check. And you get to go home. Okay, so you're hungry, yeah? You know why you're hungry? Well, it's past dinner time, sort of. But it's also because your mind expends a lot of energy. When you think, it makes you hungry. Yeah.
Looking at those chips.
Alright, come on, we're almost there. Let's check. Let's check like something with the sevens, yeah. So what's that say there? 38/7 times. Let's do 38/7 times 63/32. Yeah. How do you do that? Yeah, so the 7 cancels with a 9, right? And then this makes a 19, and this is a 16. Yeah? What's that? That's like the one's 90 plus 81. Yeah? It's 16. Hello, 我送他们下来啊。我叫他们下来。Alright, we're just gonna finish. So what's 171 on 16? It's 10 and 11 16th, is it? Or 11 minus 5 16th, you know? So this will round up to 11. Okay. We can do a few more. 44 on 7 times 3 over 2 is like 66 on 7, right? 66 on 7 is 9 and 3/7, which rounds to 9, yeah? Yeah? Yeah, we're pretty much at the very end now. You can do 3 on 2 times 63 on 32, which is 189 on 64. 189 on 64. So 364s would give you 192. So that'd be 3 minus 3/64, which rounds up to 3. Yeah? Okay. I don't know, maybe you can take a piece of paper and just check these in the car home or something. So it's like, basically, I want you to times 27 on 28 by, let's see, by 3 over 2, 38 over 7, 44 over 7, and see that you get 1, 5. So if you get 1, 5, 6, yeah? Then it's 1, 2, 3, 4, 5, 6, 7. That's an 8 there. 9, 10, 11, 12, 13, 14, 15, 16. Okay? So all you have to check, so if you want to take a note of this, you can. So 27 on 28 times these 3 numbers, okay? And also 3 over 2 times 38 over 7. And that's a way of cutting it in 4, where you get all the whole numbers on your round. Okay? So if you can write that down, then you can go. So the stuff in green. Okay. Okay, you got it? Alright, you got it, Ernest? Okay, good. Okay. Alright. Thank you. So you must be feeling very tired, very drained, very hungry, right?
No, I only feel hungry.
Just hungry. Oh, that's very good.
I'm just sitting here. Just feel tired.
Alright, your parents are waiting for you.
What?
Yeah, take hold of it.
Do we both go down?
Yeah. Alright guys, so I'll see you guys next week.
Okay.
All
Bye.
right, thank
Alright,
you.
thank you.
Alright, thanks Aiden.
See you next
See
week.
you next week.
Yes, it's on the left. And it's level 1. You're probably going the same elevator, so.
Bye.
I have to turn off the screen.